Here's a few more examples of factoring using the GCF. In all these cases, and even as we move forward and learn new factoring techniques, we're always going to start looking for the GCF. Remember, when we look for the GCF, the greatest common factor, we're looking for anything that divides evenly into both terms. It's probably best to have a strategy, and I think it's a good idea to always start looking at the coefficients, right? The numbers in front of all the variables. When you look at 15 and 10, those are both multiples of 5, so 5 needs to be part of the GCF. Now the other thing to consider is if they have any variable factors in common, and even though the first term here has an x squared, the second term doesn't have any x's. So it turns out that the GCF for this entire polynomial is just 5. The way we use the GCF is we take the GCF out, we set up parentheses, and we want to leave space for as many terms in the answer as we had terms in the original polynomial. So since we have over here 1, 2 terms, we should have 1, 2 terms here. Okay. Now the goal is, what do we have to multiply 5 by so that we end up back at 15x squared? Well, 5 times 3 makes 15, and since we didn't take any of the x's out, we'll leave the x squared behind. Next thing we have to do is figure out 5 times what is going to give us this minus 10. Well, 5 times negative 2 would make negative 10, and there's no x's to worry about. So our answer, just to clean it up and make it all look consistent, is going to be 5 times 3x squared minus 2. Remember that factoring means to write things out as a multiply, and here we factored the answer, the original polynomial, written it out as a multiply. Now in the future, when we start learning more techniques, we'll have to ask ourselves if this part in the parentheses can be broken down a second time. But in this case, it can. Now, as always, you can check your answer by multiplying it back out. I'm going to do this one in my head. 5 times 3x looks like 15x squared. That looks good. And then 5 times minus 2 looks like minus 10, which also looks good. But if it's easier for you to check it out on paper, write it out, you can always do that. Here's another couple of examples. Again, we're going to start looking for the GCF over here. There's no coefficients, or I should say here, the coefficients don't have any common factors. So there's no number that divides evenly into 3, 7, and 8. However, when we look at the variable terms, we can see that each of these has at least one a. So when we go to factor this one, the GCF is going to be simply the variable a. Okay? We have 3 terms inside. You can see the 3 terms here. 1, 2, 3. So we leave 1, 2, 3 terms inside. Now, just a quick thing about the signs. If the thing you take out as the GCF is positive, then we would expect the signs up here and here to just come down as is. Now, if you happen to factor out a GCF that has a negative in it, then that could certainly turn the signs around. You can either just make that a rule, or you can just sort of look at it and analyze it. I think that's the safer route to go. Again, the plan is, what times a would bring me back to this first one, 3a cubed? Well, we need the 3, and we need to get from a to a cubed. That means we're going to have to leave an a squared behind, so that when you do the a times the a squared, you'll get a cubed. So a squared. The next thing we have to do is look at this minus 7a squared and think about what times a would get me back to minus 7a squared. Well, I need a minus 7 for sure. I'm only going to need one a here, because a times a gives me a squared. Now for this last term, the plus 8a, I'm going to look at what happens here. I need to get back to 8a, so I'll have to do a plus 8. Okay? The answer here, a times 3a squared minus 7a, so minus 7a plus 8. Okay? And that's the finished answer. Now again, you can always check your answer by multiplying this back out. Do a quick check. I'll do this one on the paper screen, I should say. And it works. You can always check your answer because you already learned how to multiply polynomials. It's an important and easy step to do. Every once in a while you'll make a mistake. Maybe you'll put an a squared up here And then when you come down here and check it, you'll get a cubed, and then you realize, oops, that can't be an a squared, and you'll be able to catch it. And not only see that you're wrong, but you'll be able to fix it too. Okay? So we've looked at cases where we have just a coefficient, we have just a variable. There's all kinds of cases, and that's why you really have to practice a bunch of these. When we look at this one here, we look at the 9 and the 35, and they don't share any common factors. Right? And then when we look at the variables, there's an x squared here, but there's no x in the second term. So it turns out that there's no GCF. Right? So we don't want to just leave this question blank. Right? When you leave a question blank, it makes it seem like you didn't know what to do. So in a case like this, where there is no GCF and it can't be factored, we can say either very clearly can't be factored, which describes what the problem is. But we have a nice word for that in math, prime. Right? I would accept either answer, and sometimes your teacher in particular wants you to learn and use the word prime. As far as I'm concerned, if you tell me it can't be factored, that's good enough. Prime refers to prime numbers, things like 11 or 17, right, numbers that don't have any factors other than 1 in itself. And there's a lot of important uses for that in the world, but that's for another day. Okay? It's important that you practice these, look at all the different variations, and don't try to memorize it so much as try to look at it, figure it out, identify the GCF, write it, fill in the blanks, and see how many of these you can do. The more you do them, the easier it should get.